Get started. So thank you everyone for joining us. Today we're here to talk about Navtech Radar, a very exciting technology for us here in Canada. So to overview kind of the agenda we'll be looking at, we're going to start with an introduction of our panelists and the technology and company itself. We'll move into the success the technology has had in Europe, then talk more openly about its suitability for North America, and then just a general open discussion Q&A. And so guys, please, as we go along, please submit your questions as they come up. That way we have a nice list at the end for Phil to help answer us. And so just moving to the next slide, I think I covered it up here. So with us today, we have Phil Avery, the Managing Director of Navtech Radar. He's also the co-founder. You have me, Michael McGuire. I'm the General Manager of Stinson ITS. And also Ajay Kaushik, our Director of Technical Sales. So thanks for joining us, guys. I'm going to pass it over to Phil to talk a little bit about the history of Navtech Radar and some of their successes.
Thank you, Michael. So yeah, just a brief introduction to the company and what we do, and hopefully give you a bit of a flavour of the kind of organisation that we are. The company was founded in '99 as a result of some research and development work that was done at the University of Sydney, and that was around using radars for, in fact, it was for industrial automation applications where they needed to see through dust and smoke and poor weather and things like that, so you could get reliable operation of large machines in adverse conditions. We started the company doing that, and then over the next 20 years since we founded the company, we've taken that same technology and applied it to highways applications and other applications such as security. We are a very much a technology-led company. We design radar systems and processing software for radars. That's all we do. We don't do anything else. Over 75 employees now, growing fast, over 30% growth over the last 5 years or so. And something of note is that we do design, develop, and manufacture all the equipment and software in-house. So that's that we're dedicated to doing that. So we are the design authority for all aspects of the system, all the hardware, all the firmware that runs on the radar itself, and then all the post-processing software as well. And that's based at our facility here in Oxfordshire, just 10 miles south of Oxford. At this time, we have over 2,500 radars installed in highways around the world, 30 plus countries. I think it's about 46 countries in total that we've actually sold our units into worldwide, ranging from quite a concentration in Northern Europe where they have poor weather conditions and the system is very popular there, to New Zealand and Australia where we also have systems. So it is genuinely used across the. We do have two systems in Ontario in Canada for wildlife detection. I think it helps demonstrate the versatility of the system on Highway 416 and 411, where there the system is looking to detect wildlife, not actually on the road, but before it gets to the road, to give drivers a warning of what's happening.
Perfect.
So yeah, a little bit about how we got to where we are. So the company was founded in '99. It took us a while to get going. The first use of Navtech technology for highway safety was actually in 2009, so it's over 10 years ago. And that was actually that was in the UK, where we were designing a system for incident detection in a 2-kilometre dual bore tunnel in Surrey, just south of London. And that's was looking for stopped vehicles. It was looking for debris on the road. It was looking for vehicles going the wrong way. And that was one of the very early tunnel safety systems that we developed. And then later in 2013, we actually deployed the wildlife detection system in Canada, as I mentioned earlier. And then we started to do much larger deployments. So the M25 in the UK, there was a large deployment of over 50 radars there, again for stopped vehicle detection, and we also did a section on the south part of the M25 in London. And as some of you may know, the M25 is a busy highway. Those particular sections are very busy, and that's why they were chosen for the deployment. And there are a total of 8 lanes, 4 lanes going in each direction. And then later on in 2019, we were involved in putting a system into the largest subsea road tunnel in the world, and that's in Ryfast in Norway. There, it's a 28.8 kilometer tunnel total both ways, and that has over 102 radars installed in it. So as you can see, over the 20-year period, we've gone from effectively developing the system with small projects up to large-scale deployments in some of the largest road systems or largest road projects in Europe.
Excellent. Well, thank you, Phil. I'm going to jump in now to talk just a broad overview of the technology and some of the key features of it and advantages of its use in Canada. So the detector that's used by the ClearWay system, it's actually a 360-degree radar, and the core technology, the radar type, is an FMCW radar, and engineers and traffic folks in Canada would be familiar with this. It's what's used by the side-fire radar units that are currently used for count stations on highways. The big differentiator with Navtech is that radar is paired with a motor, and that sensor is then rotated 360 degrees 4 times a second. And by doing that, it allows the system to fully scan its surroundings and track all the objects of almost any size down to 25 centimeters within its range, which is about 500 meters radially or a kilometer diameter. And so because it can track everything that it sees, it's able to do a lot more than the core functionality of stop vehicle and queue detection that you typically see. We'll get into it a little bit later, but it could do things like wrong way detection, pedestrian detection, and traffic data gathering. To review a few of the key features of the system, it has an extremely fast detection rate and low false alarm rate. Because we can see everything and track it so clearly, we're able to generate alarms within about 5 seconds of them occurring, and these thresholds can be adjusted. Also, the system's extremely good at all-weather operation. Because it's radar, it's not limited by lighting on the roadway or weather conditions, so it can see through rain, snow, even dust, smoke, and fire, which is why it's very useful in tunnels. The system's also very low maintenance and highly reliable, so there's almost no regular maintenance for the radar sensors themselves. There's no cleaning required like you would with other camera-based systems. All that's required is once every 5 years, there's a motor belt assembly that needs to be changed on the radar itself. And the units are also very reliable. The mean time between failure is measured as 9 years. And so that's from all their experience. It's actually measured to be 9 years. That's not a calculated value. And the system's also future-proof, which is always a big consideration. We've talked about a few of the applications. On the next slide, I'm going to go into a few more. But we can do a lot of stuff with the data that the system is generating. Because you know the size of the objects, the speed, and the location of them on the roadway, there's a ton of future applications that can be developed, in particular around connected and automated vehicles and driver behavior and things like that. But there's lots more to come, and this system is very future-proof. So as I mentioned, there's a lot of simultaneous functions that can be performed by the system beyond stop vehicle and queue detection. Because we can see everything, we can also generate traffic data on all the roadway that's covered by the sensor. Usually these are provided along a long stretch of roadway. And so it's like having a count station at every point along, so you know exactly how many vehicles, what size those vehicles are, as well as how fast they're going, very accurately. We can also, as Phil mentioned, do wildlife and pedestrian detection, whether that be adjacent to the roadway as well as on the roadway. We can, again, because we know the speed and the volume of all traffic traveling along the roadway, we can measure and calculate travel time along the whole corridor, as well as track wrong way driving vehicles. There's also some added benefits like close following and debris detection. So if something's larger than 0.5 meter squared, we can actually see that on the road and send alerts for that too. Now I'm going to just jump over to the next slide. This is a short little video. It's got some kind of cheesy arcade music to it, but it's actually very useful. This is a live system. Well, not live right now, but this is recorded from a live system in the UK. And it just walks you through how the technology works, how it converts the raw data into processed digital data, and then how that generates alarms on their system. So I'll just let that play now.
Welcome to our demonstration of ClearWay, the radar-based automatic incident detection solution developed by Navtech Radar. Navtech Sentinel is a user interface that shows all the configured radar in a system and their position on a background OpenStreetMap. In this example, we have 10 radar along the Oxford Ring Road. Each radar covers up to 500 meters in range, therefore a kilometer diameter area. In the software, carriageways are designed to reproduce the road layout. Each carriageway is split into 100-meter sections. This allows the software to generate alarms on a section basis and not target by target. Sections are also used to detect traffic congestion. This enables the suppression of alarms only in areas where traffic is queuing. Each radar sends raw data to the signal processing software. These represent the radar reflections from all objects within line of sight. Within the radar image, you can clearly identify significant objects, both on and off the road, including trees and vehicles. The static infrastructure is analysed over a number of scans and is filtered from the real-time data. Once the stationary objects are subtracted, we are left with only moving targets, which are now being displayed in red. At this stage, a multi-hypothesis tracker associates the movement of each object and creates tracks. Each track has information on the object, speed, direction, position, and classification. Based on the track characteristics, alarms can be generated for people, slow, stopped, or reversing vehicles. In this example, you can see the detection of a person walking alongside the road generates alarms in both sections 3 and 4. Once an alarm is raised, it is stored in a central database and alert is sent via XML to a third-party traffic management system, providing the alarm location and associated description. Thank you for watching our demonstration.
Perfect. So guys, as a reminder, again, if you have any questions, please put them in the question chat and we'll get them. We'll have 15 minutes at least at the end to review your questions. So I'm going to pass it over to Ajay now, who's going to, review kind of some of the challenges we have in Canada and have an open discussion with Phil around those. I can't hear you, Ajay, if you're talking.
Sorry, yeah, I was muted. Okay. Thank you, Michael, and thank you, Phil, for the presentation. And congratulations, Phil, on your fantastic success story. Now I'm going to talk about Canada here, how your system is suitable for Canada. And I'm not sure if you know this, but I and my family moved to Canada about a year ago. And honestly, driving on Canadian highways, especially Highway 401, was a cultural shock to me. The first time I was driving on it, I was driving at the speed limit was 100. I was driving at 110, and I was the slowest guy on the whole road. And I was a little worried if some cop is going to stop me and something is going to happen. But no, everybody else was going at 120 approximately, and that was a cultural shock to me. In fact, there was very high traffic. So, frankly, highways in North America have a lot of traffic, and it's very fast traffic. Do you think a ClearWay system is going to be suitable for such kind of traffic?
Yeah, thanks, Jose. Absolutely. So there are some very busy roads in Europe, actually, particularly in the UK around London on the M25. So as I mentioned earlier, that's an 8-lane motorway, and there we have very high traffic rates. And yeah, everyone drives at 80 miles an hour, which is like 130 kilometers an hour. That's pretty normal. So I think those busy times, it's over 1,000 vehicles per hour per lane, and everyone's driving fast. So absolutely, the system, there's no reason why the system doesn't work in heavy traffic and fast moving traffic. In fact, fast moving traffic makes no difference, and we've proven it in those environments as well. So yeah, we're confident that it'll work in those circumstances.
Would occlusion not be a problem on highways with a lot of truck traffic, especially if it's very heavy truck traffic?
Yeah, so clearly it's a line of sight sensor, so that's worth bearing in mind. Obviously, it can't see through things. Actually, it can see through some things, but generally, let's assume it doesn't see through things like solid metal objects like trucks and things. So you do get occasional occlusions, but as you saw from the data there in the earlier video, you get continuous surveillance of the area. So if you get the odd occlusion, then that's not a problem, because it will pick up the data afterwards. It'll identify the vehicles, it will then track them, and then it has a certain amount of coasting as well. And also, if you have multiple radars, it will see the vehicles from the other direction as well. So yes, there are occlusions. Obviously, that's physics. We can't change physics, but the system operates perfectly okay. And particularly when you're looking for incidents, then often the incident, something like a stopped vehicle or wildlife, then if there's an occlusion, it'll be temporary, and then the system will be able to see it. So it's not a problem.
Oh, nice. Now that you have mentioned wildlife, so here in Canada, we are very serious about wildlife. I'm not sure if you're aware, but on roads passing through wildlife reserves, we spend up to 25% of capital budget to ensure wildlife safety by building fences and making bridges for animals to cross, and we're very famous for that. So animals can run very fast, and do you think ClearWay can detect these incidents and warn drivers within that short period of time?
Yeah, absolutely. And I think it's worth pointing out there that the way the system works, because it is different to other systems. So we are aware of other systems that detect the moment that the wildlife gets onto the road. And that's not how the ClearWay system works. Because you have a 360-degree surveillance radar, effectively looking not just on the road, but off the road as well, then we can detect the wildlife before it gets to the road. Therefore giving warnings to the drivers on the road that wildlife is about to get to the road or it's on its way, and then maybe they should slow down or stop. So that gives us plenty of time, or gives the system plenty of time to warn the drivers. And I think that's a key difference, because it is a full surveillance radar. It's not a simple on-off or broken beam type system. We can look off the road, analyze the data, see if there's anything moving, and then give drivers warning well in advance of them arriving at that location.
Perfect. So my next question is about commute time. Did you know that GTA has one of the worst commute times in North America, with about 15% GTA residents spending over 60 minutes traveling every day? In fact, the situation is not very different in Montreal or Vancouver. I recently read a report, and I'm going to see what that. Yeah, it was from Canadian Chamber of Commerce in 2018. And they said that Canadians spend about 10,000 years annually stuck in traffic due to congestion. How do you think ClearWay can help us reduce commute times?
So ClearWay's been used in a number of applications where the intention is to ensure that the road is moving freely. So clearly, if you're looking for stopped vehicles, then obviously stopped vehicles in a busy highway can cause a build-up of traffic almost immediately. If there are pedestrians on the road, or in fact any incident at all on the road, then the system will detect that. It can also monitor traffic flows, traffic rates, traffic behavior, all those kind of things, and allow the road operator to have that information to maximize the flow of traffic through the road network. Clearly, we can't make the roads wider or improve the number of lanes or anything, but we can ensure that the infrastructure which is there is used to maximum efficiency.
Oh, weren't you making that extra lane? And I know in the UK they don't use any more shoulders, and you're helping them.
Yeah. Absolutely. So that's a particular application where they have taken the emergency lane and they've made it into a running lane, and that's great. So effectively, you take a 3-lane highway with an emergency lane and you turn it into a 4-lane highway, effectively increasing the capacity of that highway by a third, 33.3%. And that's what's happening in the UK with the smart motorways. They're actually turning the 4th emergency lane into a running lane, and that's great. It does increase the capacity, say, by a third with the current infrastructure. The one downside of that is then you need to ensure that if there are any incidents on that road, you know about them immediately, because clearly you don't have an emergency lane. And that's where ClearWay helps, because it can immediately warn the road operator there's an incident. And it was identified that when you do that, turn a highway from a 3-lane into a 4-lane, then although actually the road is safer, there was one particular risk, and that is a stopped vehicle in a live lane, and that's where ClearWay comes in and detects that particular incident.
Okay, so you can actually increase the range sometimes.
Yes, we can. We can certainly provide the safety system that allows you to do that.
Perfect. So my last question, and it's not the least, the famous Canadian winter weather, where temperatures can drop up to -40 degrees, and in some locations it can drop even further. Does your system work in such condition, and how reliable is the incident detection during low temperatures?
Yeah. Firstly, the system is generally extremely reliable. I think, as Michael mentioned earlier, there's a 9-year mean time between failure, and that's part of I suppose it's part of the company DNA, the legacy from producing industrial automation systems, where you're sticking radars on haul trucks and mining vehicles. They need to be extremely reliable. So that's some kind of part of the way we design systems. And also, when you're doing those kind of applications, you do need to ensure the system is extremely robust over wide temperature ranges. So as far as operating at -40, yes, it operates at -40, no problem at all. You'll be aware that a radar system that doesn't have the problems of being iced up, like a camera system or something like that. And obviously, being radar, it does see through snow and rain and fog and dust, and inherently it's good at that. That's why it's used for aviation, marine, and military applications. Radar is very popular there for that exact reason. If you were to have a very thick layer of ice on the outside of the radar, yeah, that might cause a problem. But short of that, it's going to work in all circumstances. And in fact, as I mentioned earlier, one of the areas where we've had a lot of successes in Northern Europe, in Norway and Sweden, and clearly there they have very adverse weather conditions as well.
Oh, perfect. That's all the questions that I have. Michael, do you have any questions about technical side of it?
Absolutely. Thanks, Ajay. So now I'm going to jump into a couple more technical questions. Ajay and Phil were just talking about kind of the suitability in Canada. So I'd like to talk about kind of follow on from that on reliability and how that works for ClearWay. So as you know, Phil, product reliability is an important consideration when considering a new technology. Can you talk a little bit more about the reliability of the system, especially in regards to, I think you touched on it there, but regards to maintenance and system uptime and its ability to have redundancy?
Yeah, sure. I think it's worth mentioning here how the actual architecture of the system is inherently reliable. So typically you would have the various types of radars. There are staring radars, obviously just looking in one direction with no moving parts. Our system's a scanning radar, so it does have moving parts, but it's worth pointing out there are no active moving parts in the radar. That's to say that all the RF electronics, all the processing electronics, everything that you could consider to be subject to being unreliable if it was being rotated is not being rotated. All the electronics are based in the base of the system, and the only rotating part is basically a piece of metal which reflects the signal. So there are no active rotating parts. There are no signals being passed through slip rings. There's no signals being passed through rotating joints or anything like that. So it's that, and that is the patented technology that Navtech have that allows you to transmit and receive 77 gigahertz signals through a single point, which allows you to use those passive rotating parts and keep the system very compact and very reliable. And that's proven in the data that we get from the field of the 9 years mean time between failure in pretty occasionally pretty adverse conditions. Sometimes I wouldn't say the UK is particularly adverse. We sometimes get down to -10 degrees centigrade, and maybe if we're lucky it gets up to 30 in the summer. But in places like Norway and Sweden, it is. And similar radar technology is used in very rugged environments, like on vehicles, autonomous vehicles and things like that. So we learn from those applications, and we ensure that the radar is designed in such a way that it will it'll survive a long time. As far as availability, and service is concerned, the radar needs a service once every 5 years, and that's to replace the belt and the pulley. So that's a fairly long service interval. In fact, we've never had any failures at 5 years. So you know, it's a preventative maintenance scenario, and that's it. And it has a design life of 10 years, and people do run them for longer than that as well. So it's a long, it is, if you look at the overall cost of ownership, then it's yeah, it's a very effective system.
Excellent. Yeah, actually that low service interval is one of the most interesting parts for me, because we've maintained cameras for years, and cleaning those lenses are a big pain for that. So I imagine that's a big impact on the total cost of ownership. Can you talk a little bit about how that factors up in relation to the total cost of ownership?
Yeah, so we see with these systems that are installed, particularly on you start to get real data when you look at, say, for example, a 50 or 100 radar installation across a wide area. The first thing to note is that because the radar has a long range, you end up covering a lot of area with just one radar, or however many there are. So you're not having a system every 100 meters or every 200 meters. It's typically every 700 meters or more that you have a system. So that's the first thing, is that you don't have a large number of systems, therefore the infrastructure is low. And then for when you come to servicing, you're not servicing as many radars. They are at the side of the road. They're reasonably easy to get to. The actual service time itself is quite low. As I say, they've got a very long service life, 5 years, and a very long design life of over 10 years. So interestingly, whenever we've looked at it, the total cost of ownership, although the devices are reasonably costly when they're first purchased, the cost of ownership over a 5 or 10 year period is extremely competitive with any other technology that you might choose to use.
Yeah, I can certainly imagine so. Yeah, that's actually leads into my next question. When I kind of learned about stop vehicle detection years ago, it was almost always focused around thermal or optical cameras, and seeing a radar-based technology was actually very exciting for us when we were introduced to you guys a couple of years ago. So can you talk a little bit about, outside of just the deployment, spacing and stuff like that, as far as the core technology itself and how it performs? We've typically seen them as, like I said, thermal or CCTV, or even LiDAR sometimes. Can you talk a little bit about how Navtech compares to those other technologies and how it contrasts?
Yeah, I think that this is the key sort of benefit of using radar technology is its all-weather capability. So something that I suppose is worth mentioning is that if you were to look at the radar image that the radar produces, it looks exactly the same. It's not actually, it is human readable if you look at them enough, but I don't suggest you do that. But the image looks exactly the same regardless of the weather conditions. If it's raining, if it's snowing, if it's dark, if you've got bright sunlight, whatever the conditions are, the radar image looks exactly the same. And therefore, once you've developed the software to interpret that signal, it will work in all conditions. And that is in stark contrast to other solutions. So if you use a camera solution, for example, anyone who's been involved with those will know the challenges involved with tuning them. Firstly, when it's dark, and then when it's light, and then when it's raining, and then when the sun comes out, and then the sun goes in. Each one of those scenarios is a different scenario for the software to deal with. So consequently, and there may be a scenario that you haven't seen yet. You know, a combination of bright sunshine and rain from a different direction, or maybe very strong winds and the rain's blowing across at a different angle or something. All those scenarios have to be learnt by the software, and consequently it's extremely difficult to produce reliable results. And then you'll have the physics of the situation against you. You cannot see, just like a human cannot see through heavy rain or fog or snow. The light does not penetrate those particles in the atmosphere, and therefore you don't have any data. No matter how good your software is, you do not have the data to do the analysis. So cameras suffer from that, and obviously in the same way that humans cannot see in those conditions. LiDARs also suffer from that because they use light. LiDARs are notoriously unreliable, particularly when they're dirty or when they have rain on the enclosure. As people are probably aware, if you have a raindrop and you try and shine a LiDAR beam through it, a laser beam through it, it just deflects off in a different direction. It acts as a prism and it sends the light in a different direction. So they're notoriously poor for that. You do get very good data from cameras and LiDAR systems and thermal systems as well, but you don't get it in all circumstances. So I think this is a route that other technologies have been through. You can get great performance, but as soon as the weather turns poor, then you're fighting against physics. It will not perform. And of course, as we all know, it's when the weather is poor that you need the system the most. You know, on a bright sunny day, actually stop vehicle detection system, you can see for yourself. It's when it's dark and raining and there's poor visibility, that's when you need the system to work. And unfortunately, that's when most other technologies fail because they can't see in those conditions.
Precisely, yeah, exactly. That's what I kind of came across in my research, is that the false alarms is the biggest frustration with adoption of this type of technology. So I think that's a key differentiator. So moving on to another question here. So as you know, an important consideration in addition to the functionality of the system is kind of, as we move towards connected automated vehicles and all these new technologies like 5G that are coming out, people want to consider the future readiness of technology. And I touched on it a little bit earlier, but can you maybe add a few more comments on what you guys are working on and what others are researching in regards to your radar and future applications for it?
Yeah, sure. So because the system actually provides surveillance data effectively, I'll use the word surveillance in the sense of a radar, you get all that information. You can then interpret that information and give the customer what he's looking for. So for example, stop vehicle detection, obviously a fairly simple application there. You're looking at the data and you're saying, well, that vehicle has stopped. But you could also look at the data and interpret and say, well, how many vehicles are in each lane? How many vehicles are going above a certain speed? How many vehicles are going below a certain speed? You can also do count and classify, where you're looking to see how many trucks there are or how many cars there are. So all that information is there in the data. It's a case of doing the analysis and then passing that data to the customer. And we do get customers who ask for new specific applications. I think we discussed this before, Michael, where people were looking for people jumping queues at junctions to ensure that people didn't suddenly stop in the second lane and then try and push into the other lane. So that's all about, again, analyzing the data with a specific idea in mind. So that's what we can do, and I think you've mentioned some of the other applications as well. Does that answer your question? I think that was
Yeah, absolutely. Thank you.
Yeah.
Actually, that queue jumping was exciting to hear. We're right here on the 400 in Ontario, and we have this application where there's a big lineup of cars getting onto the 401 every single day, and there's always dangerous queue jumping that's occurring. And I've always wondered how they can stop that. So it's cool to see.
Yeah, no, you were asked to do that a while ago. Actually, it's yeah, and that's because all the data's there, and we are interpreting it and giving the customer what he wants. So it's very data rich. I think that's something worth emphasizing.
Exactly. Yeah. No, I like that. So we're kind of running tight on time, so I'll just get to our last question around data security and privacy. So if you could just talk a little bit, as you know, privacy is becoming a huge thing as cameras and license plate reading and everything are becoming more and more embedded in the traffic industry. Can you talk a little bit about, one, the security of the system as far as data integrity, and then also, how friendly the radar is towards privacy?
Yeah, so the security of the system, firstly, the actual data that it collects is not really that useful. There are no images of number plates, there's no images of faces, there's no images of cars or anything. It's kind of blobby radar data. It's not really human interpretable, and it's encrypted. So really, as far as data security is concerned, firstly, the data is not really that useful to anyone, and secondly, it's encrypted anyway. And that really speaks to the privacy piece as well. You're not going to be able to, apart from deciding whether it's a truck, a bike, or a car, the data doesn't really give you anything other than that. Yeah, so you can't use it to encroach on anyone's privacy. It's simply not there in the system.
Perfect. Yeah, that's an exciting element of it as well. Thank you very much, Phil. So we're running a little tight on time, but we are going to go over to answer any questions that you guys have. So I'm going to move on now, and Samantha, if you can read out any of the questions that we got there, then Phil can jump in and answer them.
Sure. So we did get quite a few questions. The first one is, how many radars do you need to cover 5 kilometer corridors?
It will depend on the layout of that particular 5 kilometers, how many corners there are in it, etc. But typically, we would suggest one radar every 500 to 700 meters. So that gives you a range. I mean, quite often it's nearer the 700 meters. We've done systems at 500 meters to give extra coverage. So yeah, there is a little bit of a range there, and also depends exactly what you're trying to achieve. If you're looking for debris on the road, you may need to move the radar slightly closer together depending on the size of the debris that you wish to detect. But if you're looking just for stop vehicle detection, you can easily space them 700 meters apart.
Okay, and then the next one, do all the radars communicate between each other to deliver travel time?
Yeah, we do get asked that question quite a lot. You can get, you get average speed in each section that's covered by the radar. Do we pass the track from one radar to the next? We can. We generally don't do that. The reason being that it's not 100% reliable. When you could get occlusions, the track may not pass from one radar to the next. It is something we're looking at. So I would say that it does work, but we're not saying that's a fully reliable feature yet. Be able to track a car, move from one radar to the next radar to the next radar. And actually, we're big fans in using the right technology for the right thing. There are other ways of doing that using Bluetooth and things, and they're quite reliable. So yes, but I wouldn't necessarily rely on the system tracking a vehicle over a long range.
Yeah, and I'll just throw in my 2 cents there too, is that re-identification is a very interesting application, but as far as travel time, if we segment the road into 50 or 100 meter segments, and we very accurately track the speed of objects in each of those, and so that goes for the entire coverage area of the radar. And so if you know the average speed in each of those sections, then you can very accurately measure what the current travel time is. So even though you can't re-identify an object, you can get very reliable corridor end to end or any point to any point travel time.
Absolutely.
Perfect.
This system is the system designed only for highways? Is it not really designed for use within a city?
Yeah, we have, most of our deployments are on highways, but I guess that's more historical than anything. I think there's real potential for use in cities. I was on a call just earlier this week, actually, where someone was looking for what they refer to as upstream information from junctions. I really do think there's great potential there. I think the real need has come from highways to date, but I do believe that there's going to be great potential for using long range all-weather sensing in cities as well.
Yeah, absolutely. Funny enough, we were on a call this morning about pedestrian detection and cyclist detection to see try to automatically detect jaywalking. And I know in others or areas of our business, we've had a big focus on Vision Zero and safety. So I agree completely. There's lots of urban applications for this as well.
Is the product NEMA temperature rated, negative 34 degrees Celsius to plus 74 degrees Celsius?
Sorry, how low does it go?
Negative 34 degrees Celsius.
Yes, it does. Yes, negative 30, and the top end plus 74. Did you say?
Yes.
It's actually currently rated at plus 60 because that's what we've been asked for. We have supplied systems with higher temperature, so the answer is currently minus 40 to plus 60. If there was a specific requirement to go higher, again, as I mentioned earlier, we are the design authority for all the hardware and software, so that's something we could look at.
What height is the radar mounted from the ground?
Typically somewhere in the region of 4 to 5 meters. So above the height of a truck, but yeah, not too high.
Is there any concern for installing Navtech Radar on elevated bridge structures like Garden City Skyway? Will bridge vibration affect its performance?
No, it won't. And we've got many, actually not many, but we have a number of bridge installations, and that's exactly why the radar was chosen for those installations, because small vibration, in fact, even fairly large vibrations don't affect it. And again, that comes back to the resolution of the image. If you've got a camera image, it needs to be pretty much spot on because you've got that height, you've got a visual image to interpret. With a radar, it's lower resolution, So that's the disadvantage. The advantage is vibration doesn't matter for those sectors. So we have tried and tested solutions working on bridges that, for the very reason that they vibrate and cameras don't work.
Does the radar work in tunnels?
Yes, absolutely. All our applications, actually not all, but I would say 95% of our applications in Norway are in tunnels. So that was one of the early uses of the radar. There's legislation in Europe that says any tunnel over 3 kilometers long must have an incident detection system, and hence the industry was looking for a reliable incident detection system for tunnels, and that's, yeah, I would say probably 50% of our radars are in tunnels.
How much expertise do we need to calibrate and configure the system?
So how much extra?
Expertise?
Oh, expertise, right. How much expertise? So there is a certain amount of expertise required. So we work very closely with our system integrators. Actually, we're working with Stinson's here, where we would provide a support for the system integrator. So there is some expertise required, but that's part of our offering, radar, the software, and support in doing the system tuning. So there is some, but not as much as you might imagine. Actually, it's getting easier and easier all the time as the software gets better, as the system becomes more mature. And actually, we've now with these larger installations, obviously we have to make it easy to install. Otherwise, we will be spending all our time doing it ourselves. So no, there is some additional, but not very much.
What are the options for powering the unit?
Two simple options: 24 volts DC or power over Ethernet. So both those will work.
Can the radar be mounted on sign structures? How far off the roadway should it be mounted?
Sorry, can it be mounted on what structures, Sam?
Sign.
Like the
yes,
overhead kind of sign structures?
Yeah, absolutely. In fact, the large deployment we're doing in the UK now, one of the key requirements is to mount as many radars as possible on existing infrastructure. Because you imagine if you're deploying, in this case, up to 800 radars across a network, the first thing they're going to do is mount as many as possible on existing infrastructure. You can't put it on a thin post because it probably would move around too much if you had strong winds, but anything that's reasonably substantial is fine.
Yeah, and just on the second part of that question, Sam, because we're, as far as how far from the roadway, because it's a line of sight system, we do want to be as close to the roadway as possible to reduce any, blockages or line of sight issues.
Hi, we are kind of running out of time here. There are a lot of questions. I would like to answer 2 more questions and then probably conclude this from the questions that have been asked. So one of the questions that have been asked is, how does the radar performance change with height or wind? Let's say if there's a lot of wind around, does the radar perform properly?
Yeah, so wind won't affect it. Again, as I say, as long as it's mounted on a reasonably, well, firstly, the only thing that could potentially affect its performance is if the thing that it was mounted on moves. That's the only thing that potentially, it does not get affected by wind. The actual radar function does not get affected by wind. And there you can, as I say, it works on bridges, so you can get a reasonable amount of movement and it'll be just fine. So it depends on the structure that's mounted on. And sorry, AJ, what was the other question? Height.
I think that's, yeah, it's height.
Yeah, so height. The issue is that if you mount the system too high, the way the beam works is it illuminates the ground underneath the radar. If you mount it too high, then the close-in performance will not be optimal. So you can't mount it too high, otherwise the close-in performance starts to reduce. So that sort of there's a tolerance there for 4 to 5 meters, maybe a bit more. We've had some systems at 4.5 meters, but that kind of height.
One last, sorry, go ahead, please, Samantha.
I saw one here. It says, do any other technologies interfere with the radar?
No, they don't actually. That's a very good question. I mean, one of the benefits of FMCW radar, because it's a swept signal. And these radars are also directional as well, so they're continually changing the position at which they're looking effectively. There's the only thing that could possibly interfere is another 77 gig radar, and obviously we have lots of them deployed on the road, so we know that doesn't happen. But anything at any other frequency, no, it won't interfere with it at all.
Okay, the last question for today. What have you done for V2X connection, and how does the data collection in case of car accidents in urban areas? How do you do that if an accident happens, let's say?
So currently we would be relying on whatever infrastructure is there. So we are not a V2X company, so we don't provide communications, but we provide the data for people to communicate to the vehicle. So I think there's a very rich data set which we can use, but we don't actually supply the communication channel for doing that. We haven't got time to go into it now, but there's some very interesting ideas about how you could supply information from across a wide network to, for example, a vehicle, so that you can see around corners and over the horizon and things like that. We haven't got time to go into that now, but that's a very interesting area to look into.
Absolutely. All right, thanks, guys. There's tons of questions here, and I'm so happy to see that. We are going to follow up with all of them in our follow-up email, which will include a recording of this. And this is our biggest webinar to date, so thank you so much for taking the time, and Phil, especially you, taking the time to join us today. I'll just briefly mention that our next webinar is a month from now on November 4th, and it's going to be with Ajay again and James Delamere, our president, and it's going to be focused on connected work zones, opening up possibilities for safety, mobility, and project management. So again, thank you so much, everyone, for attending today, and we'll follow up with an email later this afternoon with the recording and all the questions. Thanks so much. Bye-bye.
Thank you, everyone. Bye.